excited to be the moderator here for this panel, and really looking to have a discussion with our panelists about their companies, what they do, and how they operate. And so I'm going to begin by I actually won't read the bios. I'll turn it over to our panelists, and we'll start with Corrado de Gasperis here to introduce yourself and your company here to our group.
Thank you. I'm Corrado de Gasperis. Company is Comstock Inc. Recently changed the name from Comstock Mining Inc. because we own and control about a 12 square mile, 10,000 acre mineral patent package that is the Comstock lode up in Virginia City. But about 4 years ago, we pivoted and invested in first lithium-ion battery metal recycling company. We have a 200-acre storage site in Mound House, Nevada, which is in Lyon County. And we have a 136,000 square foot manufacturing facility in the Tahoe-Reno Industrial Center, which is Story County, Nevada. And we have a third business, which we're not here to talk about today, but we are in the business of decarbonization. And we own 100% of a company called Comstock Fuels, of which we make woody biomass-based cellulosic fuels, carbon-neutral fuels that drop right into the existing infrastructure for liquid fuels like diesel, like sustainable aviation fuel, et cetera.
Thank you very much.
Thank you.
Chad?
Sure. Hi, everyone. My name is Chad Yeftich. I'm with Ioneer. We are developing the Rhyolite Ridge Lithium Boron project in Esmeralda County. We've been at it about 6 years. From the state of the project, we're currently going through the NEPA permitting process that Deborah outlined so wonderfully in the last hour. So we've done a lot of work to have a mine plan of operations that was deemed to be put into that process. Scoping's ongoing right now. We've had a definitive feasibility study from the engineering side since 2020, so that we have a point where, from a financing perspective, we have a joint venture partner, Sibanye-Stillwater, who's agreed to put up about $500 million to finance the project. Just last month, we received a conditional commitment from the Department of Energy for a loan for up to $700 million for the debt component of the project. And we've signed offtake contracts with Ford, Toyota Panasonic, and EcoPro, where our Nevada lithium will stay within the U.S. to be put into cathodes and then into electric vehicles. What is interesting about, and what we'll get into on the panel, from a process perspective, what's great about the lithium resources in the U.S. as opposed to what's found elsewhere in the world, and particularly in Nevada, is that from an energy consumption to turn that rock into the purified white powder, it's far less energy intensive. So whether you're talking about the brines in Latin America that use solar power, so free power, but it takes a long time to get from point A to point B, or what happens in Australia where that process to make that purified white powder requires high temperature roasting, which is one reason why it happens in China. The energy costs and the disposal of waste happens there. So it's really great that Mother Nature has bestowed upon the great citizens of Nevada these resources that we can all try and develop. So that's a little bit about us.
Dr. Hodge?
Yeah, I'm Vice President of Power Sources at Lithium Battery in Southern Nevada. And in that position, I'm responsible for bringing up the company's cell manufacturing facility there. What brings me to this panel is really few steps back in my past, where I got into the lithium ion industry about 20 years ago when I took a job with a company in Southern Nevada to basically scale up their process for making lithium iron phosphate. So the process basically takes the lithium carbonate that's produced, we've heard a lot about that, iron oxide, phosphoric acid, mix those all together, react them, and pull out lithium iron phosphate. And the process for making cathodes is very similar to that. You know, the chemistries are different, but they all start out with lithium. some active, in most cases like a strategic metal, and reacted at high temperatures, and what comes out of that process is a material that a cell manufacturer can use. Since that position, I've moved on to mostly making cells and designing cells, and in doing so, I've gotten sort of tied up in the rest of the supply chain for lithium-ion cell manufacturing, which is not only lithium-based cathode materials, but also graphites that need to be manufactured, electrolytes that also need to be manufactured, and lithium is a key component of those as well. So, as we're talking about the lithium-ion battery industry, understand that it involves a supply chain that's way outside, but critical to the lithium loop that's being discussed here.
Thank you very much. So I like to offer the caveat before I ask questions about this industry that I'm a humanities major. I was a history major and a political science major, and do not really understand the breadth and depth of most of what these discussions are. It's fascinating. I won't tell you about my chemistry grades in college either. But good.
There won't be any math.
No test, I hope. So why is having chemical or midstream operations and expertise important to Nevada's role in the new energy economy? I'll start with Corrado, if that's okay.
No, absolutely. So first, let me say also, I've been a miner for the last 10 years, and the complexity, the difficulty of securing the natural resource and bringing the material online is prerequisite. I came to Nevada 12 years ago, so as an outsider, one of my observations was that we mine a lot and we export a lot. And it pains my heart that we make, more gold, here in Nevada than probably three other, we're probably the fourth largest producer in the world. 100% of it is exported out of this country internationally, and it's gone, right? So when you think about that, what are we doing with our wealth? So the criticality, right, of being able to take those materials here and advance the value, advance to value-added products. Now, first step for us all, be it a miner or a recycler, we do both, is getting to battery-grade materials. That's not a layup, right? That requires real expertise, real metallurgy, real chemistry, real process. That's valuable. But if we're taking those materials and advancing them into precursor cathode active materials, cathodes, electrodes, anodes, right? Some of the more critical components that are material based, then we've got something sustainable. We've got something of much higher value that will then attract more. So you're seeing it, but I feel like we're only at the front end of establishing an economy that's truly closed loop, that truly has those intermediate value increasing, and hopefully people aren't underestimating like what it takes to do that. So everyone's running around on the recycling side, secure this, secure that, promote this. We kind of think, if we can make honey, the bees will come, right? So we got to get to battery grade, and then get beyond that, right here.
I'll embellish upon that a bit. So if you think about half of the lithium today is coming from Australia, and they're selling a 6% concentrate. That sells roughly for sort of $1,000. There's bonkers spot prices, but call it that. But then when it's refined into the battery grade lithium chemical, that's a $20,000 product. So here, what we're trying to do and what we're able to do, again, thanks to Mother Nature's endowment, is capture that 20,000 in Nevada for its citizens and furthermore for U.S. security. And if we look at the different parts of the supply chain for EVs, if one assumes that there's any reasonable level of EV adoption, that critical point where one can toggle the switch for the auto industry on and off is really that purified precursor. So it remains so important to our security as a nation, but also just capturing that economic value for not just those of us in industry, but the communities that we're serving, and having those intermediate jobs, not just the direct jobs, but the indirect jobs that all this can create for our industry.
So you said the toggle switch for the car manufacturer, auto manufacturing industry. If I understand that correctly, are you saying battery grade lithium is the limiting factor for the expansion of the auto industry into the EV world?
And again, there's lots of things that are important, but in Tim's chart last time about that split between the supply and demand, if that's not there, then you're not going to go any further. You don't have a cathode, you don't have a cell battery pack car. But think about the duration of how long it takes to bring up one of these battery grade facilities or battery grade chemical facilities. We've been at it 6 years. Tim mentioned how long Thacker Pass has been more. And it's certainly a permitting issue in the US, don't get me wrong, but it's intense chemistry. You just don't fashion upon this. So you're not going, there's lithium deposits around the world, but what's critical is taking that rock and making that purified white powder. And that over time has proven very difficult. There's been one greenfield lithium chemical project that's come into commercial production, and I believe the last 40 years that's in Argentina. So it's hard. We're all after it, and certainly with the thematic of electrification, there's more capital, there's more government support, it's there, but the science is hard too.
Jim?
Yeah, so Lithium is, our primary chemistry that we use is lithium iron phosphate. Right now, today, I cannot buy domestically produced, and include Canada on that, domestically produced lithium iron phosphate for our process. It all has to come from China, essentially. And that's really kind of a shame because of the different battery chemistries out there, LFP is the one where the raw materials for it can be entirely domestically sourced. I think the US is the second largest producer of phosphate rock in the world right now. There's abundant iron oxide sources out in the southeast United States, but there's no one making LFP. There are 2 companies that are bringing up lithium iron phosphate plants in North America, but their scale-up rate, as I've talked to them, is our little 40 megawatt hour per year cell factory in Southern Nevada is going to really push their scale up. So, if I can tell people anything here, this business of converting lithium carbonate to battery grade materials is going to be critical to this whole electrification process that's out there.
So in the midstream of the supply chain in the state of Nevada, it sounds to me like you said that we need a truly full supply chain, all 7 stages being built out. Tell me more about that. What's missing and what do we need to do that, Corrado?
So we have the regulatory infrastructure to enable something like this, but it needs a tremendous amount of additional resources, right? If you think about NDEP or Nevada Department of Environmental Protection, Division of Environmental Protection, it has two roles, right? It needs to protect the environment, which they take very seriously and spend 99% of their time doing, right? And then it needs to help us grow prosperously. You talk to the bureau chiefs and they're like, is that our job? Let's check with the governor. Oh yeah, that's our job. When you do those 2 things, then you accelerate the speed at which we can prosper. Of course, we want to do it safely and protect the environment, but we got to do it faster. And the need for speed and the need to be protective should not be in conflict. We need more resources. We're one of the states that has a better regulatory infrastructure, in part because of the mining foundation. Let's leverage that and move faster. We also need human capital. We need to attract more human capital. So maybe this is the answer to your first question, not the current question, but if we get more material science based, if we get more innovative, we just won a DOE grant on fuels with University of Nevada, Reno, right? Then we get more material scientists, more chemists, more condensed matter physicists, more. Not only will we then be more reliable in solving the exact points that these gentlemen are referring to, we're going to start innovating some new things, right? And then we will start to advance. So instead of, I remember a former governor a couple administrations ago saying, we don't want to be Silicon Valley. We want to manufacture their ideas. Disagree. Let's bring the ideas here. Let's bring the R&D here. Let's bring the material science and innovation here. Then we create something that's much more sustainable. And I think then you'll attract the companies that want to both develop and manufacture here. So we have the space, we have a lot of the infrastructure. We need more infrastructure as well. More infrastructure. I think, when Musk started Gigafactory number 1, there was irrational exuberance. It was incredible. We were all excited. Then he pivoted to Texas, and people were like depressed. And I said, he's coming back, because the one thing that they desperately need is capacity, right? But why did he pivot? One reason, not all reasons. There's much more infrastructure there to build it out quicker. But then they got to come back. We still need more infrastructure. So.
Thank you. Chad or Jim?
I guess it's, we also are working within a broader industry. So when we think about the different stages, the car companies who are existing, so ex-Tesla, they're going to build factories around the country, and that's fine. And the materials that we deliver to them, they need to be, what the customers want is something that's consistent and usable. So there are times when they have technology where they might want to apply some process at the end to take purification levels up or change a spec of some sort. And that might be best right before it goes into the cathode plant, which might be next to the cell plant, which is next to the assembly plant. So we might not have all the steps here in Nevada all the time, but that might, in my mind, be okay. We want to capture as much value as possible. Tesla's anchor here is great because it gives us that, but we need cell capacity, and we need to figure out how to incentivize that. But we won't have failed if we aren't at all the steps, because so long as we're keeping it in the U.S., in my opinion.
Yeah, I mean, absolutely. If you look at the bill of materials for a typical lithium-ion cell, it's maybe 24 different components or materials involved there. And, so I'm buying conductive carbon out of Belgium. My separator comes out of North Carolina. Electrolyte eventually will be coming out of Louisiana. Unsure where LFP is coming from. So there's this, it's not really a supply chain, it's this supply web you have to deal with. So to necessarily say we need to bring all of that, or even necessarily some of that in this intermediate supply chain back to Nevada, is kind of trying to impose economics that may not make sense for each of those processes.
Might be the wrong model. So is there benefit to operating under a single, and I understand it's double because you have the federal, but a single state's regulatory process? I guess I'll throw that out to the group.
In short, yes, because you only have to learn one set of regulations, one set of offices to deal with, right?
And it kind of, that's a very complicated scenario because we are in a wonderful state that has a lot of public land. So the permitting process in our state is far different than another state, but that state might be more densely populated, which has its own, own challenges and what have you. So I think that it's to try and have a process that one can follow efficiently, and that there's motivations on sides of policymakers, the citizenry, and industry to do that efficiently. To me, that's mana I'm having.
Yeah. Well, and one thing I'd add is that there's another layer of government we all have to deal with, and that's the local governments, which the complexities of that can potentially wipe out any complexities might be involved in dealing with it with the state or even at the federal level.
How so?
More offices, and they tend to be more, in some cases, less sophisticated in terms of industrial processes. So it's a longer learning process for both sides, right?
Mm-hmm. Interesting. So pause here to see if we have any questions from the audience, see if anybody has any questions for our panelists here. Not seeing any. Okay. Just wanted to take a moment to do that. So tell me about some of the upcoming projects or opportunities for partnership that you may have within your organizations and what you're doing and the different companies that may be a part of it. Anyone want to go first?
Sure. Our project, as I say, we're getting up what will be the first of different stages. We've got offtake agreements in place, as I mentioned before, but we also have memorandums of understanding with Lithium, with Dragonfly. Dennis is here in the back, to try and further support the Nevada supply chain in as much as we, as a group, can. And we'll look like any good mining and chemical company. We're going to look for expansion for many years to come and do it sort of adjacent, likely to where we are. So we're looking to expand those business opportunities.
This is maybe where, recycling and midstream sort of, interface, but we never felt that, just recycling a battery to black mass was sufficient. Certainly it's necessary, in a recycling process, but we partnered early on with a Singapore-based startup that created a process that we thought was novel to take black mass and go directly to precursor cathode active materials for all current lithium-ion battery types, NMCs, LFPs, and everything in between, and also producing a battery-grade lithium carbonate in the process. So we're establishing front end for recycling. We think this area, this region, there's 9 mega waste accumulating regions in the country. This happens to be one of them because of our proximity to California and our own size. But then go from there to highly pure black mass so that we can have efficient extraction of the minerals necessary and feed that into leapfrog, going to the commodity and just selling the commodity and start producing an intermediate product, for cathodes.
So how does the waste come in, and I'll get back to you in a moment, how does the waste come into the recycling process?
So it comes in any form of lithium-ion battery, from a Tesla pack to your iPhone, battery. Our system that we've designed can handle all that. We want to take all of it, as safely as possible, and then producing a black mass that can be fed, into any battery type system that we would like to produce. Now, we had to, this is a good segue back to the local county permitting, we had to separately permit a storage facility, because unless you go full RCRA permitting, in a recycling or processing environment, we are not allowed to store batteries in the same location as the destination processing facility. So Nevada's regulatory regime has concluded, and I think in a attempting to be super helpful, we'll give you a RCRA light, which we'll call a written determination. You can process universal materials just as if you had a RCRA permit, but we have a big caveat. You can't store the materials at the site. So you're seeing some of these upstarts bifurcating their locations, one for storage and one. But when we went to the local county, the local community advisory board, I mean, videos were being shown of people running out of, a site with their hair on fire, batteries exploding, I mean, it was like, I was in shock. I was like, oh my God. And we had a lot of resistance to a very remote, secluded, protected storage area. But then we engaged the Lyon County Central Fire. We heavily educated the community on, the safety protocols, the heat monitorings, the staging for if and however a fire could occur, and we got unanimous approval, at the county level. I think we're the only ones so far to have a fully permitted separate storage facility, but inch by inch, step by step, building this chain.
Yeah, well, so in terms of like alliances and relationships, we all saw the projected demand for lithium versus the projected supply of lithium, and there are similar charts like that out there for about every battery component you can name. Separator, electrolyte, demand here, supply like this. So, as a cell manufacturer, we are actively looking up our supply chain and identifying who are the critical suppliers for our components in the near future. Ioneer is one of them. We were talking with separator manufacturers to put in place long-term supply agreements just to kind of protect that supply chain as much as we can. Because the whole electrification process, based on this limited amount of material that's going to be out there, is eventually we're going to get there to where those projections are taking us, but it's not going to be a smooth transition. There's going to be a lot of noise as new choke points are identified along the supply chain. So it's going to be a number of years of kind of playing this whack-a-mole kind of thing of dealing with one choke point after another.
Yeah.
So far I've heard some of the challenges are, the chemistry is hard, which I have no doubt, and that's a challenge. The intellectual processes for building what you all are building here, workforce development, making sure we have a trained workforce that can meet the industry needs. You've got a regulatory structure between the federal, the state, and the local government. What does Nevada need to do to capitalize on the opportunity presented by your industry in the future?
Yeah, want me to go first?
Sure. Sorry.
I think there's a lot, right? I think there's a lot. I would go back to first, opening up the speed of the regulatory process. Don't make it less safe, just make it faster, right? I think that it also needs to be. I was overjoyed at the state of the state, when the governor said, we're open for business. It needs to be known, right? If it's perceived as opposite, then there's resistance. And I think there is some perceptions, that maybe Nevada's less developed, less ready. I think we need to counter that mindset in a solution-oriented way, not in a promotional way, right? We need to market, but we need to be ready, right, to help these companies come in and establish themselves. I think it could be daunting because I think we're only scratching the surface of the magnitude of midstream manufacturing that could come here. I think we're only scratching the surface. So you get a Tesla and these monsters like starting to come in, it's exciting. But, I would be shocked if, Tim doesn't convert GM into building a plant here in 15 years or something, Like these companies are going to come. And I agree with what these gentlemen said. We don't have to have every company in every step in one state. I agree with that totally. But we've got more coming. I think you're going to see us being one of the fastest growing states in terms of this, midstream manufacturing in the nation. We have properties in Silver Springs, Nevada. which most people would drive by and not realize existed. Okay? People come in, they tell us they're talking to people in Texas, they're talking to people in Montana, talking to people in Arizona, Nevada, right? We almost always make the top 4, right? I don't know that our hit rate is 25%, right? But it should be. So we need to look at those competitors, if you will, and make sure, and I don't really think they're competitors, I agree. If they all win, America wins. I'm on that bandwagon. But we should get our fair share, and we need to be ready for it, though. I think we're less ready in terms of the infrastructure, as insofar as that. University, more students, more education, more workforce, more infrastructure.
I'm thinking about things and to, again, embellish on what was just said. We're capital constrained, both human capital and financial capital. So trying to make those two systems more efficient, and certainly human capital on the engineering side and is paramount. But also we need to better utilize the human capital we have for the administrative functions that are necessary for making this system work. So whether it be most of this, of course, is happening in more rural communities. That certainly have tribal communities there as well. So better being more inclusive of the folks that are out there to help grease the wheels of commerce, if you will, on when we're trying to administratively get a permit or do surveying activity, things like that. These are ways that we can create good jobs and bring this all together faster. Then as well on the capital constraint on the financing side, these all are very expensive projects. You're talking billion-dollar projects here. And when we're competing at a global scale with the folks in Asia, where you sort of get a commitment for low-cost money and you get an enormous check with no strings attached. That doesn't happen so much in the US, and to the extent it doesn't, that just makes us all less competitive on a global scale. So and Nevada does a great job of helping incentivize, but just appreciating that Nevada's not just competing against the US or domestic Canada or whatnot. We've got to compete with folks in other continents, particularly Asia, where folks will get a $30 billion check to an industry. I mean, that just doesn't happen. And we have to appreciate that if we really want to build something here, we got to make sure that folks will want to invest in it. And to do that, you've got to get that risk return right, and we've got to be competitive there.
Yeah, I'll just say a few things about the human capital side of things, which is kind of an ongoing question in the battery industry in general, because with all the growth going on, if you go out and try and hire someone with experience in cell manufacturing or battery assembly, good luck. Right? And having said that, the types of skills that I'm looking to bring in to my factory are not necessarily what you would associate with the battery or cell industry. I mean, there's so much of the equipment is automated these days that I need people who understand programming PLCs, who understand pneumatics, understand mechanical transfer mechanisms, all that kind of thing. Front-end process of making electrodes is very chemical engineering intensive. So, I guess my message to local community colleges and universities is I wouldn't worry so much about teaching students like cell manufacturing skills or battery manufacturing skills. It's giving them a solid engineering background. I need chemical engineers, I need mechanical engineers, I need electrical engineers. I can teach them the battery side of things in weeks, months. But if they don't have the background, that's a much tougher job.
So one of the things that I find fascinating is it's such a new industry in the state in terms of there's so much innovation and these different companies that are coming up that it seems each one is very different from the other. What are some things that are unique about the processes that you use to develop the battery products that you have that are different from others?
Sure. I'm sure. So I love that question because we have a tremendously unique thing going on. So we last year invested $7.5 million, and this year another $7.5 million in a company called Quantum Generative Materials. Right? There's 34 people, from chemists to condensed matter physicists to machine learners to engineers. That's the realm of this team. And they're building a neural network, right, and AI to generate new materials. So you're talking about now, instead of being in a lab and having months and months and months of trial and error on the physics that we understand and can see, right, the materials, right, moving down into the atomic and quantum mechanical level and simulating what, for example, titanium dioxide will do to 99% accuracy, and then modifying it and simulating essentially a new material. So when I asked the CEO, explain to me like what you're saying, he said, well, you remember when GM used to build a clay car and build a huge wind tunnel and then throw wind through it and see what the aerodynamics was? He's like, right, we don't do that anymore. We model that on a computer. He says, so we are now modeling matter at the atomic level. And so we thought this would give us an advantage. We thought this would, not today, 2 years, 3 years, 4 years from now. I've gone to a few conferences since then, and every major material science company, from BASF to BMW and Intel, and have some aspect of this embedded in their R&D and growing. So my fear leaving was, hey, in 5 years, if we're not doing this, we might be in trouble, right? So it's not the biggest part of what we do, right? But we felt that we have to have this amount of innovation, right, going on somehow with these materials, because someone is doing it, someone is going to do it.
Chad, Ioneer?
So in our case, again, we're extracting the rock and then we are processing that into the battery material. And so Mother Nature's endowments are all unique. So we have to come up with a specific flow chart for what we've done. We've spent over $100 million to try and understand how that process can be done in the most environmentally sensitive and economically sustainable way. We've had a full circuit pilot plant because, again, the chemistry of this can be done with computer models and such. And we have our chairman had developed a project previously, and they had done their phase chemistry, for example, through modeling and desktop, and weren't satisfied when they brought the plant commercially with the results they had. So for us, we made the investment over a 2-year period to do a full cycle pilot plant where we converted 30 tons of ore from Rhyolite Ridge into the materials that we've now contracted to sell. And those are the types of things, and my colleague, Michael Osborne's back there, he's a real chemical engineer, and what we spend each day is trying to refine, work with our partners so that we're able to do that processing in the most efficient way possible.
Yeah, so an EV imposes a pretty predictable duty cycle on the battery that's running it. The car speeds up, slows down at some prescribed rate that you can design batteries and design cells to do that. And a lot of people out there doing that, obviously, right now. And this enormous industry, in fact, is building up around that. But obviously, the battery industry extends beyond just EVs into energy storage, which has its own duty cycle requirements. Going down the list, power tools, another duty cycle requirement. As a small cell manufacturer, what Lithium can do is give a customer a cell or a battery that is specific to their application. Outside of that, you need to go to an EV company and kind of, it's a square peg and round hole kind of application. You have to make their battery work in your application. It might either end up being too large of a battery, too small of a battery, not give you an ideal power curve that you need for device operation. So what we can do is do that kind of customization to specific customer applications.
I'd like to see if anybody has any questions from the audience one more time. So 2 questions over here. Deborah.
I was wondering, I know that Chad's project, Rhyolite Ridge, is on public lands, but I was wondering, Jim and Corrado, whether or not the dominance of federal land in this state influences how you operate. And does it constrain you at all? Do you try to plan your facilities so they are on private land mainly? If you could just comment on that a little bit.
I can go quickly. The Comstock load, as a side note, right, is 2/3 public, 1/3 private. And Mother Nature did not lay the minerals out, right, in a way that was conveniently all on the private properties. And anyone who's ever been mining with a tiny sliver of a federal wedge in the middle of your mine and want to shoot yourself in the head with it understands the question, that she's asking. But having said that, when it comes to discovery of minerals, we will not have the option. We will not have the benefit. And I would love to see some amalgamation and streamlining, of NEPA and NDEP, coordination. It's been extremely frustrating. We have commenced phases on private land with the intentions of moving into federal. We've done it always transparently because the regulators' head will explode if they genuinely perceive you're trying to avoid regulation, which you're not. You're just trying to be productive and comply with the regulation. But I think that it's an asset for Nevada. It should make us like Superman and woman, but right now we view it as a liability. I mean, when people come in and look at our properties, first question out of their mouth is it on private land? They are hesitant to engage in these multi-year endeavors. And the only advice I could tell you with hindsight, being 12 years into this company, is if I could do it again, the very first thing I would do is start the NEPA process and not even think about the critical chain, right? Don't think of it on the critical chain, think of it as a feeder chain. Think of it as a feeder chain that once it's done, it will come on and be part of you. But if you wait to try to optimize it, it'll eat you alive.
Yeah, so, as a manufacturer, we're not necessarily captive to a specific location because that's where the minerals are. But we are constrained by workforce availability and also logistics. I mean, we can't build a mega plant 30 miles off of a freeway, for instance. So especially in southern Nevada, that ends up being kind of a major constraint, and just given to the limited amount of private land down there.
The last thing is, if there was a way to take advantage of FLPMA, the Federal Land Management Purchase Act, right, and truly have the state take some leadership and acquire strategic portions, in no way, shape, or form offending, the federal mandate of having all this amazing land, okay? I think that a small minority of land purchases could unblock a monstrous amount of economic productivity.
Governor Lombardo's State of the State message basically mentioned expediting the transfer of some public lands to county and private.
And it's complex, right? Mark Amadei, came through with Restore Story County. The BLM is still scratching their head on how to implement. We had a congressional act, right, cleans up an incredible amount of federal conflict, and we can't implement it.
Marcus?
Yes, I'm Marcus Johnson. Luna Sparks, you mentioned Visitors Authority. I was just curious about your opinions, being in manufacturing and supply chain. Are some of the federal and state targets to go only electric vehicle sales or non-combustible engine vehicle sales, are those realistic projections? Do you foresee them needing to reset those projections?
I'm afraid to answer because I don't want anybody to kill me. We think it's ridiculous. that it's not a lot of pressure, it's ridiculous. There's no scenario where we electrify 100%. There's none, right? And Tim made a great comment, he wasn't disrespecting recycling, he was speaking openly, right? It's going to be a tiny, tiny fraction of the total, so is EV. Now that doesn't mean it's small. You get to 10%, that's 150 million vehicles out of 1.5 billion. But remember the mining trucks and remember the airplanes, right? So I think electrification, just so nobody kills me, is a critical part of the solution, especially if we truly use renewable fuels and not fossil fuels to enable the supply chain, okay? Cellulosic fuels, which are carbon neutral, which is the other part of our business, right, can drop right into the existing infrastructure, can reduce 40, 50, 60% of our mobility emissions, of which the United States is 25% of the world's transportation emissions. So we're at the Clean Energy and Transportation Conference, right? It has to be both. And we just got a grant from the Department of Energy to advance these fuels. So we love electrification, love it, in case anybody's done, love it, right? And we love liquid fuels that are carbon neutral, truly carbon neutral.
I am very unqualified to be on this panel as well. I have an economics degree. But I'll tell you, that chart that you've seen with the spread of supply and demand, anyone who's taken a single economics course tells you that at any point in time, supply and demand have to cross. So either the demand numbers are wrong on that chart or the supply numbers are wrong on that chart.
Yeah, and so again, going back to the chart, demand goes this way, supply goes this way. That difference, for the most part, gets made up by a lot of guys driving around in diesel trucks digging stuff out of the ground. So again, ultimately we may get there, but it's going to be a pretty jagged curve to get to that point.
I want to compliment one thing that you said earlier, right? If you think about system can have a constraint. Everyone wants to say lithium's the constraint.
Yeah.
It is a constraint,
Yeah.
okay? But we are literally dealing with an interconnected series of mineral bottlenecks, an interconnected series of logistical bottlenecks, and an interconnected series of manufacturing bottlenecks. Nothing is more difficult than playing whack-a-mole in a supply chain. You said it. And ultimately, if we had one constraint, and if it was lithium, we could subordinate to that, and we would win. We would figure it out. But if you have dozens of them, and it's not coordinated, you will hit the wall, and EVs will not be able to grow unless you debottleneck it. In this case, exponentially multiple debottleneckings, or you innovate around it, which means there may not be a lithium-ion battery. Okay, we'll see. But guess what? Supply and demand is going to come into balance, right? One solution or another. So as a company, we're investing in electrification and we're investing in cellulosic fuels, right? Because it's scary.
So how did those claims get made if they're not consulting with you about these bottles?
How does California pass a law to say every single car that must be bought is electric? How does President Biden get up there and say, 2030, I'm going to be at this amount? You're mental. Like you literally, if you're a mathematician, you're laughing, right? You're spitting milk out your nose as you're drinking because there's no way you can make it. There's no way. And if anybody disputes it, I'm here. Now, what we're doing is saying, let's get as much of this material today, Thacker Pass, tomorrow with recycling, as available as possible. There will be use for it, okay? But will we electrify the world? Mark my word, not in our lifetime.
On that happy note, I'm gonna go ahead and ask you to join me in thanking our panelists here today and really appreciate the conversation. We're going to transition to our final panel of the day.